Yeah, welcome to my talk, Cause of Death, Hibernate. In the following about 50 minutes, I want to talk about common reasons why projects that are using Hibernate are getting into trouble. Because how do I know about all of this? I'm usually one of the guys that gets called if there are problems with the persistence layer in the Java space, and the team doesn't know why this happens or how to solve it. I'm working as an independent consultant, trainer, and author, helping developers optimize their persistence layer, or what would be even better, to write great, efficient persistence layers from the start. Because there's a disclaimer that I want to put here up front. You can, of course, use Hibernate to implement applications that serve hundreds or even thousands of users in parallel and that are incredibly fast. We have been doing that for about 2 decades now. But in all of my other talks, I'm usually explaining what you should do, how to do it right, and what are the things that you should better avoid. And I thought, well, that probably gets a little bit boring for you and for me. So why not switch it up? Why not take a few examples that work really well and then show how to break them with just a few small changes? And well, if you're thinking about how to kill a project or get it into huge trouble, then 3 things come to mind. One thing that we could do to get a project in trouble is to create an application that has a very bad performance. So that's not only slow, that's really slow. And then another thing that's really great if you want to annoy your users is to produce tons of inconsistent or unexpected results. And if you want to keep your manager up at night, then losing data is always a good option. So let's take a look at a few things that might cause one of these problems here. And let's start with slow performance. Let's do that in the IDE. So one thing that you quite often need to do is you need to fetch an entity and a bunch of associated entities with that. So a managed association to a different entity class. Here I'm using a very basic online bookstore example. So we have an author entity and it has a managed association to the books that author has written. And that is a standard many-to-many association. So I hope that when you fetch such a data structure in your application, you do it like this. So you select an author, and in the from clause, you use the a left join fetch clause to tell Hibernate to not only fetch the author, but also to fetch the books with it. And then you can do something useful with it, like this log message here, which prints out the name of the author and the titles of the book. And if we take a look at our log output, we can see that Hibernate executed this query statement. It selected all the columns from the author and from the book table, and in the from clause, it joined the author with the association table book author and then with the book to get everything in one statement. And that is pretty efficient approach to handle all of this. Unfortunately, that's usually not the case that we find in most projects. What we find there is something like this. We use the entity manager find method to get an author from the database or any other entity class by its primary key. And well, in general, that's not a bad idea. It's a good method provided by the entity manager, but it sometimes causes some issues. And we should see that here. Yeah. So in this case, you remember the previous test case, we used the author and the association to the books. And what I skipped over in the previous test case was pointing out that we do that outside of the transaction, which shows this pretty clearly that there's an issue with the association. Too many associations are fetched lazily by default. And that means that we either need an additional query to fetch it, or if we try to do that outside of the transaction, we get a lazy initialization exception. one of the most common exceptions in the JPA and Hibernate world. And if you Google for that, you find some suggestions on Stack Overflow how to fix that. And still a quite common one is just switch to fetch type eager and you get rid of your lazy initialization exception. Well, let's do that. So running the same test case again, and if we look at the log output, we can see that it worked fine and that Hibernate got all the columns from the book and the author table and joined the stuff in the from clause. Looks quite well, right? So shouldn't be any wrong with using this approach. Well, that changes if you don't use the entity manager find method. If you provide your own query, then recognize here this query does exactly the same as the entity manager find call. But you can see in the log output that we now executed 2 JDBC statements. And there's the one to get the author, and there's the one to get all the books of that author. So if Hibernate is not in control of the query, then it uses a second one to initialize the association. And while this might be rather small inconvenience, if you're just fetching one author, it's a great way to slow down your application if you're fetching a bunch of authors. So let's select all authors in my small test database. Don't worry, it just contains 6 authors, nothing more. But we already see that we have 7 JDBC statements here. And you see lots of queries that initialize the books association here. And just want to get the author. Congratulations, you added the n+1 select problem to your application, which is the most common reason for performance problems. And it's rather easy to introduce and quite often hard to spot because, well, it's either here fetch type eager, or there are several ways you can cause the same problem with fetch type lazy. So using eager fetching is for sure the easiest and best approach to create an application with slow performance. Better approach, as I mentioned earlier, is stick to the default for too many associations, which is fetch type lazy, and use a joint fetch clause to fetch your associations. We saw it earlier. This triggers one SQL statement that fetches the author and all associated books. And it does that reliably, not like the eager fetching that we tried just a few seconds ago, where we saw that Hibernate used an efficient query when it was in control of the statement, but a very inefficient approach if we wrote our own query. So writing a query using a joint fetch clause is the right approach with one JDBC statement here and this SQL statement. And when you do that, you sooner or later run into a query like this one. We saw earlier that using a joint fetch clause is a great idea to fetch an author with their books, or basically any entity class with an initialized managed association. But if you do that with 2 associations, you might get a multiple back fetch exception. And that tells you that you cannot simultaneously fetch multiple bags. So you might ask, what is a bag? A bag is an unordered collection, which is a data type that's specific to Hibernate, and you get it if you're fetching or if you're modeling an association as a Java util list. You can avoid it by switching it to a set. Just a few small changes here. Like this, and down here. Okay, now we're using a set. And by replacing this list with a set interface, we can now execute the same test case again, and you will see that it works fine. When doing that, please keep in mind that this statement here creates a product. It joins the books with all authors and with all reviews. And that means that you can get a pretty huge result set, where, depending on how many books an author has written and how many reviews there are on average for each book. And due to that, some people recommend to never join fetch more than one association. I don't like these strict rules, because that would mean that a too-many association that on average contains 3 records should be treated the same as an association that on average contains 10,000 records. And it's pretty obvious that it makes a huge difference if you multiply something with 3 or with 10,000. So something that works on smaller associations, like multiple joint fetch clauses, can be absolutely fine, but you need to double check your application's domain and the number of elements you expect in your associations before using multiple joint fetch clauses. Otherwise, you will, again, introduce quite some performance issues, possibly on your database, for sure on your network, and within your Java application, because please keep in mind, Hibernate has to map all the data that we get back with this query and map that to real Java objects. So the mapping will take quite some time, and the garbage collector will be really busy afterwards. What would be actually better would be to use a DTO projection that just uses the data that we actually need in our specific use case. So if we just want to print out the title, the author names, and the number of reviews we got for that book, then we don't need all the reviews. We just want to know how many there are. So why not let the database count that? Here. Let the database do the work. It has been optimized for that. And well, then we also only select the title, the first name of the author, and the last name, and put all of that into an unmanaged class, so not an entity class. It has 3 attributes. We have a simple constructor here. And we just call that constructor here in, oops, like this. Here in the query, we start with the keyword new, fully qualified class name, and the few constructor parameters to run that. You can see that this creates an even smaller and more efficient SQL statement. And if you attended my previous talk about the new features in Hibernate 6, then you saw the result transformer feature. You could use a tuple transformer here to do the same transformation. The alias to bean result transformer that I showed you in that session does exactly the same as the constructor expression, just without the default constructor. So yeah, here's the query. It just selects the few columns that we need, the title, the first name, the last name, and it counts the number of books, reviews, instead of selecting all of them. And that gives us a much better SQL statement and a much faster performance. So any questions about the stuff that I showed you so far? If you have any questions, feel free to post them in the chat. I'm happy to answer them at any time, and it's much easier to answer a question while I'm still talking about a specific topic than trying to figure out which example we need when we do the whole thing at the end of the session. So another thing that we should take a look at is caching. It's one of the more trickier ways to slow down your application. Quite a few developers just introduce caching if they want to improve the performance of their persistence layer, right? You quite often hear that the question, if a query is slow or basically anything is slow, can't we cache the result? Wouldn't that be better? Yeah, well, it would be better if the cache works right, if you configured it in the right way, and if it's a good use case for caches. So the first thing you can do to make sure that the cache actually slows down your application instead of improving its performance would be to cache any data that, that you change quite regularly. So on average, to have an efficient cache, you would need 9 to 10 read operations for each write operation, just as a rule of thumb. And a good way to make the cache inefficient is, of course, cache data that gets changed all the time or not read at all. Another way to make your cache inefficient is to just rely on JPA's default caching mechanism. So I added caching to this application and said, okay, I want to enable for each entity class if I want to cache it or not. And I annotated my book with a cacheable annotation. And I did the same for my author entity. So both of them now get cached. So if we now go here and we call the entity manager find method to get a book from the database. And then I access the association to the author entities within my business code. And then I have a second transaction that does exactly the same. Now it looks like your cache should contain all the data, right? Well, unfortunately, we're still executing 2 JDBC statements in the second session. Let's see what's going on here. So in the first one, we got all the books from the database. And then we got all the authors of all books. Sure, that was the stuff that we used in our test case. And we also needed the association to the reviews. And you can see here, we executed 3 JDBC statements, and we actually put some data into the cache, which is the author and the book. So this is great. Everything looks like it would work perfectly. Unfortunately, in the second iteration, we immediately see that Hibernate executes another query to get all the authors from the cache and also the reviews. Well, that's annoying. Why is that happening? Well, by default, JPA doesn't cache the associations that are not modeled by a foreign key reference on the table that gets mapped by this entity. So when we are fetching the book entity, it would cache all the associations on which for which the book table contains the foreign key column. Unfortunately, that's not the case for our many-to-many association to the authors. There's an association table for it. It also doesn't do that for the reviews, because if we look at the reviews, it's a many-to-one association to the book. And that means the review table contains the foreign key column. So we don't have that information on the book, and we actually need to add a cache annotation to each of these associations to tell Hibernate to cache them. That is a Hibernate specific feature, and something that gets often overlooked when activating caching for an application. As you just saw, from a code point of view, it looks totally fine until here. And then you just recognize when you look at the log output that we actually had some queries that we didn't expect. So here you can see that we didn't execute any JDBC statements, and we got 4 hits on the second level cache. That means we got all the objects from the second level cache. How did that work? Well, we did the same queries as before in the first transaction. We selected the book. Then we got the oh, something strange here. Okay. Then we got the authors of that book. And then we selected all the reviews. And we put all 4 objects into the second level cache, which now includes the associations between the author and the book and the review and the book. And due to that, we were able to get all this information from the secondary cache. So any questions about typical performance problems or easy ways to slow down our application without putting anything recognizable into our code? Well, have an eye on the cache, on the chat. If you have any questions, feel free to post it there. While checking that, I will also summarize the bad performance chapter of this talk. So we saw a few ways to cause performance problems, and well, if we want to get our project into trouble. And first of all, we saw that fetch type eager caused a bunch of additional queries, which we should avoid with by using fetch type lazy. Use case specific projections is always a good approach to ensure that the overhead on the database level and when mapping the result set is as low as possible. We don't select any data that we don't need, and that ensures that we get an efficient application. For all many-to-many associations, for all too many associations, you should use a Java util set instead of a Java util list if you want to use multiple fetch join clauses within the same query statement. That's especially the case for many-to-many associations, because there you also run into a pretty inefficient update handling if you model the entity association as a set instead of, no, as a list instead of a set. And if you're activating caching, please always activate logging for your cache or the Hibernate statistics that you just saw at the end of each test case, because you need to double check if Hibernate actually used the cache or if you're just creating an overhead by managing the data in your cache without reading it from there. I see in the chat that Jochen asked, what about entity graphs? Would you recommend them or not? In general, yes. So the idea of an entity graph is the same as the idea of a join fetch clause. The only difference is that with the join fetch clause, where is it here? With the join fetch, we define within the query that Hibernate shall initialize this association. So not only fetch the book, but also fetch the authors and the reviews. With an entity graph, we can define this fetching behavior independently, either via annotations using the named entity graph annotation or via an API. In the end, the result of a join fetch clause and of an entity graph is exactly the same. It tells Hibernate to let's see here. It tells Hibernate to join the association within the from clause, and this is the important difference to a typical join, to also select the columns mapped by that joined entity class in the select clause. And yeah, you get the same behavior with an entity graph or with the join fetch approach here in the query statement. The only difference is where you define it. And based on that, I would decide if you should use a join fetch clause or an entity graph. If you have a query that you only want to execute with the same fetching behavior, then I would always use a join fetch clause. But if you have a really complex statement and you need that query statement in multiple use cases, and in some of them you need a different fetching behavior, then it might be an option to use an entity graph to define the fetching behavior independently of the query and then mix and match them as you need for your specific use case. But yeah, in the end, as I said, the result is the same, so pick whatever you like better. NBE asked, performance-wise, which is better, entity graph or fetch join, or there's no difference? There's basically no difference. The SQA statement looks exactly the same. And well, I didn't profile it. There might be a nanosecond difference in how Hibernate parses an entity graph compared to fetch join, but nothing that's really relevant for performance tests. So as I said, pick whatever you like better. I personally prefer join fetch clauses in most cases because there I have the query and the fetching behavior at the same place. So there's only one place I need to look at to really understand what's going on there. And if I see this here, then I have a good understanding of what Hibernate will do. In contrast to that, if I would just add a named entity graph to that query, I would need to check the annotation that defines that named entity graph to figure out what kind of associations are fetched. And that makes reading and understanding the code a little bit harder. And well, I always try to keep these things as simple as possible. Our business logic usually is complex enough. We don't need any additional complexity in such cases where we can avoid that. Okay, so yeah, we saw it's rather simple to introduce a few smaller things that can have a severe performance impact. But that's not the only way you can get your project in trouble with Hibernate. Creating inconsistent or unexpected results is also a pretty good way to annoy your users. And there are a few ways, luckily not too many, that can cause something like that in your application. So let's say I want to get all authors with their books, but only the authors who have written a book with a given ID. If you do it right, then you select authors, and then you use a left join to the books association and a left join fetch on the books association. And you use the join to define your where clause. And then you can print out the authors and the titles of the book they've written. And you can see in the log output that Max and Mariah Mustermann wrote book 1, 2, and 3. No, Max wrote book 1, 2, and 3, and Mariah wrote book 2, 3, and 4. So they basically both work together on book 2 and 3. And in the statement, you can see that we now have two join clauses. 1 and 2, right? Left join book author there and there. And the reason for that is simple. We have one that we use in the where clause, and we have one that tells Hibernate to initialize the entire association. Unfortunately, it's pretty easy to use a different approach, and it somehow quite often even looks more intuitive. I mean, we already joined the authors with the books when we defined the left join fetch clause, right? So I get quite often asked, why do I need a second one? Isn't it better to just use one join clause and use that one in my where clause to define my where predicates? And well, if I need the association, I just add the fetch keyword to it. Well, this is exactly the same test case as before. The only thing that I changed was removing the second join. And you can see in the log output that Max and Mariah both now only wrote book 2, which isn't true. We just saw it a second ago. If we joined it differently, we got 3 books for Max Mustermann and 3 books for Mariah. And this can actually cause quite some problems. It's not only that if we would hand over the retrieved data to the front end or use it in our business code and do wrong calculations based on that or show the user wrong information. It's actually worse. by using the left join fetch clause here, we told Hibernate to fully initialize that association. And Hibernate thinks that it did exactly that. And now we are limiting the returned books to just the book that fulfills the where clause. That means now we have an association that Hibernate is fully initialized, but that actually isn't. And that, depending on how you continue working with that entity, could actually cause you to lose some of the associations between your entities. So please, if you don't want to break your application, make sure to always use separate join and join fetch clauses. If you're using JPA's criteria API, this gets pretty obvious because you can't use a fetch interface to define your where clause. But unfortunately, in a JPQA statement, you can easily do this. And I would actually love it if this would change in the future, and if Hibernate's query analyzer would just complain about this statement here. But unfortunately, that's not the case right now. So let's take a look at something else that can create confusing results. So we are not actually creating any inconsistencies or losing anything. We are just showing the user the wrong results. But let's start with the right approach. So I'm selecting all authors from my database. Then I'm flushing and clearing my persistence context, which tells Hibernate to check all entities if they are dirty and then remove them from the persistence context. And then I'm executing a JPQL update statement. That is a pretty efficient approach to update all records in the database. And it's way better than fetching all entities and then making the change on the entity object itself. And then I select the authors again. And let's see what we print out here at the end of the test case. We see now all authors are in uppercase, which is what we wanted to achieve, right? Well, if we don't perform a flush and a clear here, then we actually do exactly the same as in the test case before, but our user wouldn't necessarily see it. So what I'm doing here is I first get all authors, then I'm updating them, and then I'm selecting them again and printing out the log messages. That's exactly the same as we did in the previous test case. And to showcase that the data was changed in the database, I'm then using a second transaction to fetch the same data again. And if we look here, then we see that the second transaction got the author names in uppercase. So in the database, everything is fine, which is great. Unfortunately, in the first transaction that actually performed the update up here, we don't see our change. And if we now return this result to the user, they will probably be pretty confused. And the reason for that is that this statement here put all the entity objects for all the author records into the persistence context, which is also called the first level cache. And without flushing and clearing that cache, they stay there. Then we change it in the database. Hibernate doesn't know which entity objects are affected by this statement and doesn't change any of them. And when we then select the same authors again, Hibernate executes the query and then says, oh, I already know all these entity objects. Let's ignore them from the result set and get them from the first level cache. So due to that, we still get the version that we selected up here and not the version with the uppercase first and last name. So if you want to know your users, make sure that if you execute an update statement, that you skip the flushing and clearing before that. Because in that case, you can be really sure that you don't get the updated result and that you create a huge mess. And another thing that can create quite some problems, and this can create actually inconsistencies in your application, is the wrong management of bidirectional associations. Oh, just see that Andre asked in the chat, is it possible to disable first level cache? Let me quickly answer that before we go to a different topic. And well, the answer is no, you can't disable it. Hibernate uses it internally to ensure that overall we have a good performance of our application. It uses it to ensure that you don't need to execute an update statement every time you call a setter method on an entity object. And yeah, due to that, you can't deactivate it. You need to know that it's there and flush and clear that. NBE asked, what will happen if we flush after updating before the second select? The result will be the same. The performance will be a little bit worse. So if we move this to here, then the execution of this query will trigger a flush. That means Hibernate checks all the entities in the current persistence context if they are changed, and if there are any changes, then it triggers an SQL update statement. And then we flush it again. So Hibernate does the exact same operation again, and then we clear the persistence context. So from the end result, we got exactly the same. We flushed before and cleared the context before we executed the second query. The only difference is here with this query and this flush, we are executing two flush operations on a full persistence context with lots of objects. And if we do it before the update statement, then we perform a flush on the entire persistence context, and then we clear it. Now it's empty, and that means that this flush that Hibernate has to perform before executing the query actually happens on an empty persistence context. It takes almost no time. So the performance of flushing and clearing before the update statement is just a little bit better than doing it afterwards. That's the only difference. Yeah, so regarding the bidirectional association management, the Hibernate documentation and the JPA spec tell us to always update both ends of a bidirectional association, and then everything works fine. Unfortunately, that gets quite often overlooked, and we just update one end of the association. So let's say I have an author and a book, and I want to add the author to that book. And I only set it on the book itself. If you look at the book entity, we see that this is the so-called owning side of the association. So this end defines the association between the book and the author. And in that case, updating only one end of it only creates a minor hiccup. Let me check. What did I tell you about the update? Oh, no. The author and the book are already associated. So the author is one of the authors of the book, and I'm removing it from there. And if we now execute the test case, you can see that we created an inconsistency in our data in local cache. We see that Max still thinks that he wrote book one, but book one has no longer an author. And we removed the record from the database. So in the database, everything is fine. Within our current transaction, our data is inconsistent. The book was updated, but the author wasn't. It gets worse if we switch it around. If we take the author, or if we use the author to get the books and then remove the book from there, we not only create an inconsistency because the book still thinks it has an author. You can see here that we didn't even remove the record from the database. So on the database level, the two are still connected. And that means that if you select the same information in the next transaction, you will still get the information that the book one was written by Max Mustermann, and Max still thinks that he wrote all three books. So not only the two here, but also the third one, which we just removed. So please always make sure to update both ends of the association, and to make that a little bit easier, a lot of teams implement utility methods that manage the association. In this case, I added it to the book entity. And as you can see here, I remove the author from the list of authors of this book, and then I get to go to the author and remove this book from the list of books of that author. And that makes it a little bit easier to ensure that you update both ends of the association. So if you want to create inconsistencies, then, or if you want to avoid inconsistencies, you should always use a separate join and a join fetch clause when fetching your data. Otherwise, your join fetch clause, which tells Hibernate to fully initialize the association, actually limits the result set. And Hibernate gets an association of which it thinks that it's fully initialized, but it actually only contains parts of only a small part of the association. And that not only causes inconsistencies in your business logic and in the result you present to your user, it can actually even result in data loss. We just saw that the first level cache can create inconsistent result, especially if we are not using entities to perform any update or delete operations. And that we need to update both ends of any bidirectional association. And yeah, the best way to manage these associations would be to implement a utility method on the entity classes. Okay, we have still a few minutes left, so let's take a look at how to actually lose data. The good thing is that's rather difficult. The JPA specification and Hibernate are defined and implemented in a way that you usually don't lose any data unless you add a few bugs. And well, let's take a look at a batch job. In this case, and this is how it should be, I'm selecting all books from my database and put pagination on that query and just want to fetch the first 5. So what I'm doing here is I'm fetching the books in batches of 5 and iterating through them, which is a pretty common approach in nightly batch jobs. You obviously fetch a few more than 5 records, but you get the idea. And if you do that, then you might get into the situation that your persistence context contains lots of data and you no longer need most of it. And that slows down your application and makes garbage collection harder and everything. And a lot of developers then think, okay, let's flush and clear the persistence context. And well, if you do both, a flush and a clear, that's totally fine. Just make sure that you only do it when the size of your persistence context becomes a problem. With in Hibernate 5 and 6 is, well, maybe after a few thousand objects that you have in first level cache, but definitely not less. So you only need this for really huge applications. And if we do that, then we see that we changed all the book titles to uppercase and that everything worked fine. And we see in our log output that we fetched all the books, or that we fetched the first page of the books. We updated them, right, 5 times, each book with its own update statement. Then we fetched the next batch and so on. So that worked fine. That changes if you only clear the persistence context. So if you don't flush it before you clear the persistence context. And the dangerous thing here is that the operation we actually want to perform is we want to clear the persistence context, right? We want to get rid of all the overheads that slows down our application. Unfortunately, if we tell Hibernate to just clear the persistence context, it does exactly that. It doesn't check if there are any dirty entities. It only clears the persistence context, and that means that for the first 10 books in this example, we didn't perform the update statement on the database. We just did that for the last 2. Right? Here you see the 2 update statements. Before that, we just did select statements, no flushes. And that is because the clear doesn't perform a flush. If you want to do a flush, you need to trigger it yourself. So please always perform a flush before clear. And the last thing that I want to show you is how to remove data that is connected with other entities and why it can be a problem to use cascading here. So what I'm doing here is I'm selecting an author, the author with ID 1, get all their books, and then I'm removing the book here, and then I'm removing the author from the book. And if the book doesn't have any author, I'm removing that book as well. And only after I'm done with that, I'm removing the author itself. So what happens here? In the beginning, before we remove the author, we have 12 books in our database. And I printed out a few books here. Book 2 was written by author 1 and 2. Book 3 was written by authors 1, 2, and 3. And book 4 was written by author 2 and 3. And after we removed the author, we see that we only removed the book with ID 1. So 2 and 3 has moved to the bottom, and then we have 4 to 12. And here you can see the same books that I logged out before. And the only change here is that author 1 is no longer in the list of authors, which is exactly what we wanted to achieve when we removed author 1. Unfortunately, this code is rather, well, it looks rather complex for just removing a record. And sometimes developers think, well, wouldn't cascading be easier? Let's cascade the association from the authors to the books. And this is risky. Cascading is only intended to be used for parent-child associations where the child depends on the parent. That's not the case for a many-to-many association. So after only activating the cascading from the authors to the books, you can see that book 2 and 3 were also removed. These 2 books were written by other authors together with author 1. But because of the cascading, we removed them as well. And you can see that down here. The only book that remained was book 4 that was written by author 2 and 3. 2 other books that previously were also written by author 1 got deleted when executing the statement. And this would get even worse if we would now cascade the delete operation back from the books to the authors, because then we would also delete author 2 and 3 and then all the books they have written, and we would basically bounce the delete operation between the author and the book table and, well, delete the entire database or hopefully get a transaction timeout before we removed everything, which would then roll back our wrong operation and avoid losing data. So please, if you want to avoid data loss, never execute a clear on your entity manager or on your Hibernate session without executing a flush operation first. And don't use cascade type remove on any many-to-many association. As I said, it's only intended to be used for parent-child associations where the child depends on the parent. There you can cascade an operation from the parent to the children. In all other cases, cascading is just the wrong approach. It's not intended or designed to be used in that case. And as you saw, it removed too many records. And well, if we would have taken it one step further and cascaded the delete operation back from the book to the author, we would even have removed more data than we already did. Okay, that's it from my end. If you have any questions, feel free to post them in the chat or reach out to me on Twitter if you enjoyed this session. then please take a look at the Persistence Hub. It's my monthly membership where you get access to all my online courses, 2 live Q&A calls each month, an expert session with either myself or a guest each month. We had Steve Ebersole, the lead developer of Hibernate at the beginning of this year, to talk about Hibernate 6. Yesterday, we had Philip Weeks to tell us something about improving the performance of our Spring Boot tests. And right, we have various guests, had various guests over the last few months, and we have a new one every month. Okay. Thank you. And yeah, if you have any questions, feel free to ask. Okay, looks like there are no questions. So thanks for joining. I hope you enjoyed it, and feel free to reach out to me on Twitter if you want to learn more about anything that I showed here on the session. There's a question from Marco. Could you explain the difference between using cascading and orphan removal for parent-child associations? Yeah, orphan removal is a feature that removes the associated entity when you remove the association to it. So when it's again something that you should use on a parent-child association, right? So this is the wrong place to use it. But let's say I would activate orphan removal here. Then Hibernate would remove the book entity as soon as I remove the orphan removal. As soon as I remove the book entity object from this set of books. A good example for when to use it would be an order with order positions. An order position doesn't make any sense without an order. And if we remove the association between order and order position, we can actually remove the order position itself. And then we would activate that here. If you activate orphan removal, then you would need, let's see here. There we can do that. So if we remove orphan removal, activate orphan removal here, we would also need to activate fetch, cascade type persist or all to activate orphan removal here. Okay. I just got the message that we have 1 extra minute for questions. So if you have a question, then ask it now. Otherwise, I think I need to make space for the next speaker. But as I said, you can reach me on Twitter at twitter.com/thjanssen123. There.